going to share my screen again, and I'm going to give a quick introduction to CHIEdge, describe to you what that is. Again, we're going to be talking about the product definition, so to speak, what the testbed, edge testbed looks like, rather than implementation. That's going to be our focus for today. And I'm going to share my screen and give you a quick presentation, and then later on, Jason, who you just met, will give you a demo of how to use our edge testbed. So, introduction to CHIEdge. First of all, I realize that many of you are new to Chameleon, so a quick description of what Chameleon does. Chameleons are renowned for their adaptability, right? They're very changeable animals, and the testbed follows that pattern, right? It adapts itself to your experimental conditions. So when you come to the testbed, you can allocate resources, whichever resources you need for your experimentations. We have a large homogeneous partition. We've got about 6 petabytes of storage. That was originally distributed over 2 sites at University of Chicago and Texas Advanced Computing Center. More recently, we have been joined by a number of other sites that are coming up that were not part of the original Chameleon plan. We've got 1 site in Northwestern, and we've got 2 sites coming soon, one at the Illinois Institute of Technology and one at University of Illinois in Chicago, and other places are configuring Chameleon site using something that we call CHIEdge, right? It's a packaging of both Chameleon infrastructure and its operational model, and allows you to deploy your own Chameleon site very quickly, right? So we're very diverse also array of hardware that consists of ARMs, Atoms. We've got a large range of different GPU clusters. We support FPGAs as well as interesting networking hardware, in particular process switches, and that's about to get even more interesting. And again, Chameleons like to change, so you can allocate all of this hardware for your exclusive use, right? So you can go and say, request a couple of GPU nodes via advanced reservation or on demand if they are available, and then you can reconfigure them completely from scratch, right? So reconfigure them at bare metal level. You can boot from custom kernel, get access to serial console, so very deep reconfiguration capability. Chameleon is a little bit different than previous testbeds of this type that came around, in that Chameleon is configured via a mainstream open source infrastructure called OpenStack. We're very proud of that, especially as we extended OpenStack to adapt it to the needs of our community, and introduced a new component to OpenStack called Blazor, which is used to do advanced reservations. We continue to work with OpenStack right now, and our CHIEdge implementation is also based on OpenStack. And this has many benefits. Like I said, we increase our impact by contributing to mainstream open source infrastructure, but we also leverage the various innovations that community develops. It also is a very familiar infrastructure, obviously, so has the advantage of familiarity for users and operators. But being part of the mainstream, it also means that there are tools that, for example, convert images between OpenStack clouds and commercial clouds, Amazon and so forth and so on, which now made it very easy for us to support both Chameleon and commercial clouds, right? So Paul Ruth, if he is in the workshop right now, somewhere on chat, will be happy to point everybody to a notebook and a paper that describes how to structure experiments over those 2 infrastructures. And then last but not least, we are trying to make it easier for others to stand on the shoulder of giants, right? So we're trying to make it easier for others to reuse research that has already been done. So in order to do that, we integrated Chameleon with Jupyter notebooks, right? So we've got credential-based integration. You can, from your Jupyter code cells, you can go out on the testbed and provision resources. And from one Jupyter notebook, as I just said, Paul will point you to one. You can provision resources on Chameleon, on commercial clouds, structure interesting networking between them, and now you can provision them on edge devices as well. And we also provide mechanisms for users to discover each other's electronic renditions of experiments in terms of images and notebooks, right? And reuse them. It's sometimes much easier to start from an example of work that somebody else did, or if you're replaying somebody else's experiment, to say, what would happen if I introduced some variation in this part or that part, right? So being able to do that very, very easily is important to us, and those are the capabilities we provide to our users. A few notes, a few words about what Chameleon looks like in numbers. Main thing I want to tell you about is that we are almost at 6,000 users. In fact, if you log into Chameleon today, you may be the 6,000th user. And of course, we've been around for 6 years and have got 3 more years to grow. Now, creating an edge testbed, right? There's the question of what does an edge testbed look like? And some of our users would answer that question with, well, it looks a lot like a cloud, right? It's like a cloud just for edge devices, and please give me the same interface that you're currently giving me to Chameleon, that has the advanced reservations and the IP assignment and the Jupyter notebooks. Just don't get rid of the Jupyter notebooks, right? Very important feature. And then others would say, well, it's not at all like a cloud, right? So first of all, those little devices, they are out and about, and they are not sitting in a data center. And so that is important, that they are location dependent. And the reason they are location dependent is that they are tied to cameras or software-defined radios or other peripherals, which allow them to get data. And the raison d'etre, the reason why they're there is that there are those sensors and they provide location-specific data. And then finally, those devices are often not server class, right? So there are many, many differences, and this is probably just the beginning of the list. So out of those two differing viewpoints came out CHIEdge, which has all the features you know and love in Chameleon, but reconfiguration is handled via container deployment for the time being. We're learning that there's both more interest and more availability on the bare metal side than we originally thought, but via container deployment for now. It supports peripherals based on an extensible plugin model, and it also supports mixed ownerships of devices, right? So we've got some edge devices in our IoT lab, but you can also add your own edge devices, which are in interesting locations connected to various IoT devices, to the testbed as well, and run experiments with that, and we'll see some examples later. And then finally, last but not least, it's still a work in progress. So if you'd like to give us new requirements or ask questions, please join the Chameleon Edge users mailing list. That's the main vehicle for Chameleon support currently, because we would like to stimulate discussion between our users. So what do those capabilities look like in detail, right? The last slide presented an outline. I typically talk about test beds in terms of support for an experimental workflow where you have a hypothesis, you discover resources, allocate them, and then ultimately you configure them in some way. Well, our discovery services right now are relatively basic, but for allocation with CHIEdge, you can rely on pretty much everything that you get in the main Chameleon testbed, right? So you can allocate nodes, VLANs, and IPs as before. You can make advanced reservation for those edge devices. You can allocate those advanced edge devices by saying, well, I want a Raspberry Pi or I want a Nano, or you can say, I want this particular Nano that is connected to that drone, right? You can say that as well. Reconfiguration is handled via containers. As in Chameleon, you get access to a catalog of images. You can configure those images further and snapshot them. And of course, you get that coveted Jupyter integration and Jupyter access to your edge devices, right? From edge to cloud resources, right? So you can structure experiments from cloud to edge. And of course, all of this gets authentication via federated identity, just like the rest of Chameleon, and access via GUI, command line interface, or Python and Jupyter. Now, what happens when you're not a user, when you're actually somebody who wants to share a device? Well, for that, we provide an SDK that automates the process of enrolling device in CHIEdge, so you can add that device on an ephemeral basis, and support for restricted releases. This is very important because that means that if you are using the Edge device for just your class, right, and you want to share it with your class, but not with everybody else, you can do that, right? Or perhaps you're supporting some application and you want to share it just with your collaborators, but not others. You can do that as well, right? And that means that you still operate this device yourself, but you operate it just for the community and leverage the expertise that we provide on how resources should be shared, right? And then users get access in terms of what I just described, and they get access not just to those devices, but they also get access to a public resource, which is Chameleon, and they get access to commercial clouds. And very soon we're hoping to have Chameleon and Fabric on the same Jupyter notebook as well, right? So we're going to show you edge devices and cloud resources on one Jupyter notebook. Very soon you're going to have access to sophisticated networking capabilities as well. And via this SDK, of course, we sometimes get questions, if I deploy my container on the Nano, will I get access to the GPU? Of course you will. And then furthermore, we have this framework that gives you access to peripherals. We support various standard camera modules, GPIOs for the Raspberry Pis, and software-defined radios for the time being, but we have an extensible framework for integrating new devices. Now, I have to mention SDK is temporarily suspended. This is because we got a lot of interest in it and are working with multiple users. And since CHIEdge is still in preview, the infrastructure is just not mature enough to support the level of effort that the operation of that requires, right? So we're working on making that code easier to operate and scalable to more deployments, and we're hoping to get that in Q1 of 2022, maybe in Q2. But in the meantime, within a month or so, we're hoping to provide an alternative that will allow you to add your edge device to the Chameleon network. So you won't be able to share your device, but if you have an experiment from your edge device to the cloud, you'll be able to implement that relatively easily. So to summarize what CHIEdge is, it's a horizontal platform, a relatively thin horizontal platform with very well-defined interface, right? A horizontal platform that spans both Chameleon-owned devices, so the devices that we provide in our lab, but then also user-owned devices, the devices that users add. The interface is, of course, the OpenStack interface, like for everything else. And the idea is that now users can, based on that platform, develop many solutions in networking, in power management, in data management. They can develop new scheduling solutions for the edge, work on security and privacy, develop new workflow solutions. And then when they are done developing those solutions, they can package it with CHIEdge to provide an end-to-end solution that somebody else can deploy, right? So CHIEdge as a platform is fantastic for computer science experimenters, but maybe not fantastic for application projects. However, if you add job scheduling or workflow management or data management, it becomes much more attractive to domain scientists, to those emerging applications that we would like to support. A few pictures from the CHIEdge developments. We were going from machine-init data centers to little devices that were configured on the tables of various team members here, and could be really practically everywhere. And a little cheat sheet for those of you who are familiar with Chameleon and know what it supports. The main things to look at here is we went from bare metal reconfigurability, which of course we continue to support in our data centers for our cloud resources, to container deployment on our edge devices. we have now, well, of course, continue to have heterogeneous collection of hardware, but now heterogeneous collection of devices also with peripherals and in various interesting locations, and owned and operated by Chameleon, got replaced by a mixed ownership model via restricted sharing. And now I'm going to disappear for a little bit, stop sharing, and I'd like to introduce Jason Anderson, or reintroduce Jason, who will now give you a demo on how all of this works.
Thanks, Kate. And hello, everybody. Just going to put my screen on now. Okay, mic check, camera check, presentation check. I'm assuming that things are fine. Yeah, so again, my name is Jason, and I'm going to be showing a bit of an overview of the Edge platform, CHIEdge, that we have built, sort of what we have implementation-wise. And it's going to be, I'm going to show you a little bit of everything. I'm going to run it through a little bit quickly just to give a sense of what's there. So as with any other Chameleon testbed that we operate, you can access it easily via by going to www.chameleoncloud.org. And let me just move my Zoom stuff out of the way. And from here at the top, you can go to this experiment section. And here you can click and access any of our sites. So you can access the bare metal sites here. And if you're familiar with that already, but notably we have this new CHIEdge section, which, because pretty new, it has some additional information about everything, such as it links to the mailing list, which I don't know if we've talked about yet. But this is the best place to get like the most up-to-date information about the development of the Edge platform, and also to ask questions, get answers. And secondly, we have a page that describes a bit about what hardware we currently have available, and like what peripherals are attached, and I'll talk about that in a bit, and also a little bit about what's planned. Finally, we have links to our documentation, and this is a good place to start, especially if you're not already a Chameleon user, because it goes over the mechanics of how do you log into Chameleon using federated identity, and how do you create or join a project, because as with the other Chameleon testbeds, we do require that you have an active allocation on the testbed in order to use the Edge platform. So you can learn about what that process is like. In general, if it means that PIs, you can request an allocation, you give a little bit of a explanation of what you want to use the resources for, and then they'll be reviewed within about 24 hours. Is typical. Okay, and the last link is to access the GUI, because we're going to look at that first. So if you hit this link, it's going to log you into the graphical user interface for the CHIEdge platform. I'm not already logged in, so it prompts me to log in via federated identity, or we support some other login methods as well to make it very easy to get in. I'm going to log in through my university credentials at UChicago. I'm already logged in by a single sign-on there, so this should just zip me through, which it does. And cool. So now we land here. This is kind of the dashboard of the CHIEdge graphical user interface. As with other Chameleon testbeds, this is built on OpenStack internally. So if you've used something that's built on OpenStack before, this is going to look quite familiar to you, maybe a little bit of a different flavor. And if you've used Chameleon before, it should look very familiar. So what we have here is CHIEdge is based on container isolation, which means that unlike on the cloud where you're launching virtual machines, or we support bare metal reconfigurability and bare metal instances, on CHIEdge, you're actually launching containers. And so if you're familiar with one of the container implementations, notably Docker, then a lot of the terminology and a lot of the abstractions are going to be very clear to you. If you haven't, it's going to be a bit new, but I'll go over a bit about what we have. So this just lists all the containers I currently have running. As with a virtual machine or something, there is a certain ability to affect its life cycle. So you can restart it, you can stop it, you can rebuild, is basically tear down and bring back up fresh. And you can also do things like, you know, a container only has one process that it's running as its sort of entry process, but it is also possible to execute like little one-off commands if you just want to check the state of something. That's just like a quick thing you can do. If I click through on one of the containers, I can get kind of a detailed output about just sort of confirming its configuration mostly. It would say this one is running, it's running a shell as its command, and I'm going to show one of the implications of that in a second. It also tells what image I launched this with and some information about its network connectivity. One of the interesting things about the Edge platform that we have is that it does not require, if you're bringing a device, you don't have to have a public network connectivity to the device. We're able to essentially hook these devices up and connect them over tunnels and overlay networks, which means that it's a very flexible deployment model. For example, in some of the images that you saw, and on one of the demos I'm going to give, it's going to be running on a Raspberry Pi that's effectively taped to a window in my apartment, and it doesn't, that Pi doesn't have a public IP address, because I'm on a residential connection, but it's still able to be connected and utilized in the platform in this way. We'll also probably hear some more demos about other interesting deployment locations. This is important. You can see the logs of the container, if anything was printed out here. And lastly, if your container is running in an interactive mode, this is pretty nice. You can actually get an interactive console normally. Refresh the page. Yeah, there we go. You can get interactive console because I'm running, normally this will just attach to whatever process is running inside of your container. In this case, it's a shell. So I can attach to the shell and I can move around. I can, install other packages if I want to. I can do kind of anything I can do inside of that container. Okay. Now, jumping back out to the containers section, you can, of course, launch a container. I'm not going to show this workflow necessarily right here in the demo. I'm going to be switching over to a different interface to do the rest of this. But all the sort of properties that you put here, again, should look pretty familiar to you if you've used something like Docker before. The image that you type here can be any image that's on Docker, published to Docker Hub. We don't yet support private registries, but it is also possible to effectively store your container image inside of Chameleon. In this case, it would be using what we call Glance, which is the Chameleon disk image service to serve that container image. So this is possible, and some users have actually taken advantage of this already. You can specify some constraints on the container if you care about resource constraints. Currently, these are not enforced at all. So your container will use the maximum amount of resources that it has available on the edge device. And I mentioned networking. You can attach these, you can actually create your own networks and then attach your containers to these networks to allow two containers on two different devices to address each other, two containers on the same device. And so this gives you a pretty flexible way to do inter-device communication. Last thing is security groups. By default, all of the containers have pretty strict security groups on them. It basically just means they don't allow any connections coming in, but this is possible to change, and I'll be showing this as well later on. So the last thing I want to show before jumping out of here is we mentioned that Chameleon is kind of interesting in that you need to make reservations for hardware. The reasons for that are there's a multitude of them. Mostly, we have a relatively resource constrained relative to the amount of users that we're serving with the test bed. And so there is contention for resources, but also a lot of the resources that we provide are very special, and you might really specifically want like one particular piece of hardware, and we give you the ability to target that and reserve just that piece of hardware for your experimentation. You can make reservations in advance as well, which lets you basically plan that, like, oh, I want to, I know I'm going to need this resource in like a week leading up to a conference, and this gives you like a peace of mind that those resources are going to be available. Kate, I saw you raised your hand. Did you want to say something?
No, I actually was trying to do Q&A, so.
Okay. I'm sorry. I just got the little thing like this.
Yeah.
Popped in
my apologies.
It's okay. So the device calendar here is really useful. It allows you to plan, basically it gives you a sense of what the testbed utilization is, and also plan for, oh, so it looks like there are, playing devices available like later in the month. I can plan if I want to get a bunch of devices, I could make a reservation starting in like 1 week, but there are some I can use immediately. The other thing that you'll notice in this calendar is that some of these bars are grayed out. And this is currently how we're expressing the fact that some of these devices have additional kind of constraints or requirements. This is what Kate was talking about with restricted devices. So maybe I have a research group and we have some IoT devices. I want to use the Chameleon platform to manage access to those devices and make that part really easy for my group. But I don't necessarily want to have other people outside of my group, outside of our university, accessing those edge devices and launching code on them. So you can restrict devices to certain projects. And some of these are restricted, like these. We can see that this Raspberry Pi, this is actually attached to a self-driving car, which requires some in-person use, so you make sure the car doesn't escape and run away or crash or do something bad. We also have some devices that have SDR nodes and or SDRs attached. So, there are some, to avoid contention on the actual bandwidth, that requires some extra coordination with the people who manage that infrastructure. And yes, but in general, what we're trying to do with the edge testbed is, yes, allow for these kind of interesting restricted devices to exist and be managed by this infrastructure, but also provide kind of a set of commodity, for lack of a better word, edge devices of various different platforms to allow anybody who doesn't have a device to get started immediately, basically. Okay, I don't think I wanted to show anything else on the GUI. We'll probably come back here just so I can sort of prove that some stuff that I'm doing is working. But what I wanted to show next is a different interface to the Edge platform. So Chameleon, I'm not going to talk too much about this, but Chameleon has this thing called Trobi, which is pretty cool. Trobi is effectively a set of packaged experiments or tutorials or demos that are packaged as usually a Jupyter notebook and some additional support files or documentation. And we've prepared several of them. Several of them are maintained by us and Chameleon, and one of them in particular is interesting for if you're interested in the Edge platform. That's called Chameleon User Guide CHIEdge. And you can launch these if you have if you're part of an active Chameleon allocation. And this is going to open up this notebook inside of Chameleon's Jupyter Hub platform. We actually maintain a Jupyter Hub deployment. Sorry, 1 second. And any Chameleon user has access to this. I'm just going to refresh my session here. So it'll let me go. Okay. And what's happening here is actually it's spinning up a Jupyter server just for me. And then it's sort of copying that notebook file in there. Trobi has some other interesting properties, and we have a few webinars just on Trobi about how you can use it to kind of as like an experiment workbench, save your work, share your work. We even support getting DOIs and being able to publish things for citation. But that's kind of outside the scope of this talk. So what I do want to show, though, is this is what we call the Jupyter or Python interface into the Edge testbed. And this is a really powerful interface because it sort of leverages the fact that notebooks are this great way of taking a topic or a workflow or an experiment and expressing it both in code and also showing like the process and the methodology behind what you're doing. And with Jupyter on Chameleon, we have a lot of integrations built in. The cool part about it is you can kind of use these special libraries and functions inside of code cells, just as Python code, and use them to kind of drive and set up experiments on the Edge testbed. And so that's what I'm going to be showing, basically doing a lot of the things I was doing in the graphical user interface, but doing it via Python. Because I'm logged in here, it sort of knows who I am. So it knows that it's going to be making all the operations on behalf of my user account. And because we have many different sites that Chameleon supports, you can use this exact same approach in bare metal, for example, but I'm going to be using the Edge site. And so I'm going to put that in there like that. And you secondly have to sort of say which project this is going to be going on. Your project might look something like this. The project I'm using is an internal one we call Chameleon. And I'll just import some libraries I'm going to be using here from a library called Python G, which is one that is for Chameleon infrastructure. It's a Python module that lets you control the Chameleon testbed effectively. Cool. So I'm just going to go back in here and we'll take a little bit of a risk and delete this lease so we can show you how it gets recreated here. So all of the main interfaces that you have on Chameleon are expressed in Python as well. And so what I'm going to do here is we have some built-in functionality to allow you to easily create a lease on Chameleon. And so I can say that how long do I want my lease to be active for, and you can target basically what type of device you want. So in this case, this is a Raspberry Pi Model 4. We also support things like Device Vendor. You could say Raspberry or Jetson, but here I'm just going to keep this the same. And let's see if this looks like it deleted that lease. So let's see if it can create a new one. So that's going, it's asking Chameleon's lease system to please create a new lease for me. And if I go back here and refresh this, I can see that it's doing that. The lease is pending. When I say that, Chameleon, you need to reserve resources in advance. We effectively support ad hoc reservations as well, which is what I'm doing right now. Or if a reservation is available or a device is available, you can reserve it immediately. But you still get the kind of guarantee that the device is going to be available for your exclusive use. So now that I've reserved this device, nobody else is going to be able to launch a container on it. I think we had bad luck in it. Oh yeah, there it goes. It was just hadn't processed it yet. All right. So we've got that. And now I'm going to switch over to actually start doing some stuff with like launching containers. And so we have this handy little function called create container, which you can pull up some information about all the options that are available here with a little autocomplete thing. But what I'm going to be doing is just launching a container that is running, that has Python available, and it's going to just run a simple Python web server on this port. As I mentioned, all of the edge device or all the edge containers, when they're launched, they by default don't allow any incoming connections, but you can say that I want to allow traffic on this port, which is going to be important because that's the port that the server is listening on. And lastly, very importantly, you have to provide which reservation am I going to be using to launch this container, because you might have reserved multiple different edge devices, and you want to target them accordingly. I should note that you can also actually target a specific edge device if you want to do that as well. If you're not really familiar with launching containers on the edge, this issue of architecture comes up almost immediately. Most of the devices that are on the edge platform are running ARM 64-bit, so you have to be a little careful to make sure that you're using containers that are compatible with this. This one is. So I'm going to attempt to launch this now, and we'll see if I will regret tearing down my original lease where everything was working. So this is going in and requesting a container now. If I jump back to the GUI, I can see that it indeed is. It's in the process of creating it. You can see all the other containers I had are gone because I deleted my original lease, which meant that the containers disappear. Okay, so we also have this little handler here that helps us wait until the container is ready. So that means that when the cell finishes, I know that I'm ready to go, which is kind of important if you're working in this interface where you might be doing like bam, 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 just executing in order. Okay, so now we can also run commands, those one-off commands that I showed in the GUI. We can do that in Python as well if that's interesting. Now, one thing I didn't show before is we actually have the ability to associate public IP addresses to the container. So what that means is basically we have the ability to make any container publicly addressable. And that's a pretty cool property because it allows me to, even though my edge device somewhere doesn't necessarily have a public IP address on itself, when it's in part of the edge platform, you can publicly address containers. And this allows me to load up this little web interface for this container that was spawned on a Raspberry Pi 4 somewhere. I'm not sure which one it landed on. So very cool. Now, one of the cool parts about the Jupyter interface is we have a lot, it's very expressive and we have a lot of flexibility here. And notably, it has good integration with sort of the local file system of this notebook sort of IDE. So I have a folder in here, and the folder contains an HTML file that just has like a really simple, just hello world. I can take that file and actually upload it to my container to the folder that the web server is currently using. And so let's try doing that. Okay, so it says it's uploaded. If I go back here, I can see that the file is there, and I can see that it has this content. And this is nice because I have a really nice workflow here now where I can make some changes to this file, and then I can upload it again, and then I can reload, and then it has the latest contents. So this is pretty nice because I can kind of have this little workstation where I can be making changes to my container in a few ways. I won't go over snapshotting in the demo, but only to say that it is possible to do. So if you are making changes to the container after it's launched, you can actually save the state of the container if that's something that is important for your workflow. And if you do that, you just launch the container in a slightly different way. Okay, so that's enough for the sort of simple run through of what we've got. Now I'm going to do a little bit more of a complicated experiment. Basically, I'm going to launch two containers, and I'm going to have one send messages to another. And then I'm going to hook my Jupyter notebook up to one of those containers and just basically read the messages that were saved. So basically, I've got one container that's going to be publishing messages, one container that's basically storing them and allowing me to read them, and then I'm going to connect to that one over the internet. Another thing to point out is that there's going to be no public connectivity between these two containers. They're going to be talking on a private network. Okay. So let's try this. Now I'm going to just start this going in the background, and let's just talk about maybe what's new. So I'm using a different image because I wanted to use, there's an image out there that has an implementation of this message system that I'm going to be using. It's called Mosquito. This is using MQTT if you're familiar with that, if you've done work in IoT or Edge before. Probably the most interesting thing here is that we have this mounts thing. And mounts are a way of specifying files that are going to be mounted into the container when it starts. And this is a really useful way for configuring containers that have at startup, basically. So you can imagine that it's not very efficient if you're just tweaking little configuration changes. You have to rebuild a new container image every time. This gets a little bit arduous, and it's a bit of a waste of time and space. So mounts are a good way of taking that which is variable, mostly a configuration file typically, and making it so that you can provide that in conjunction with a generic container image. And then at runtime, they have different behavior depending on the configuration you provide. So once again, I'm able to actually take a local file stored here in my Jupyter notebook. And it just configures a few different things about the message system. But I can provide that so that it is used when the container is launched. So this is kind of a nice other thing that you can do with the Jupyter interface in particular. It takes a little bit, you have to do a slight amount of plumbing because I have to basically tell Python, open this file and then pass the contents here. But you can do bind mounts via the API. Okay, so I've just now launched this one, the broker. I'm now going to launch this one, the publisher. So the publisher works very similar. It actually uses the same image because I can use the same software to both publish and read messages, but that's just a little detail. The main thing there's two things that are different here. One is that we are using another parameter that is available called environment. This allows it to set any environment variables that will be available to the container's process. And this is nice because I want to basically tell the publisher to publish to a message broker that exists somewhere. And because I already launched this container, I can get the IP address that was assigned on its private network by the testbed, and then I can just pass that in to the publisher, so it has it. So this is a nice way of kind of expressing this. There's a really dependency here, and we can express this in code. The second thing is I'm overriding the command. Every Docker image will have some sort of default command that it will run. And in this case, I actually want it to run something else. And once again, I am mounting a file, and I'm using this file. This is actually the command that gets run, is it just runs this script. And what this script will do is it will publish to the message broker defined by this environment variable. And it will publish basically, this is some kind of clunky way of getting some pseudo-random number from awk. So it's basically going to be publishing some sort of number to the broker every so often. That one has started, and very good. So now I'm going to connect to that one with Jupyter, but it needs to have a public IP address for me to do so, because the Chameleon's Jupyter environment is it's sort of as if you were running, currently it's as if you're running it on your laptop or something. It's just like, it's a managed infrastructure, but it's not specifically yet networked to any Chameleon infrastructure. I mean, you can still obviously interact with Chameleon infrastructure because it's a cloud and has public APIs. But just as if I was connecting from my laptop or something, the notebook needs to be able to reach my experiment over the internet for a public IP address. Okay, so this block of code here, the mechanics aren't super important. It's using a well-known MQTT client library to connect to that server that has all the messages on it. And then, I'm connecting to its public address. And then there's some little setup code to basically connect and then start reading messages. It's just going to sit there and just read messages on a loop. And now the last bit is I'm going to use some other built-in kind of common libraries like NumPy for doing some really basic, actually I'm not even using NumPy in here, but I am using ProgressPlot, which is a really cool little library that can show you a graph and you can be adding to it and it'll live update it as new information comes in. So all I'm doing basically is every time I can pull a message from that central broker, I'm going to display it and add it to the graph. And more messages are going to be added in real time by that other container that I set up to actually publish the data. And that's what you can see is happening here. So it pulled in a bunch of data that was already there on the server, kind of waiting to be retrieved. And then it just kind of sits there and it will just collect data from the central broker and update it. And as you can see, it's sort of supposed to be a random value, but it's because there's some interesting implementation with how awk does things where it looks like this. It's not very well distributed. But that's neither here nor there. The main conclusion is that there's a lot of capabilities available to you from, just as in on the GUI, I would say even more so on the Python interface. And the last thing that I wanted to do, which if you've seen some webinars before, a lot of this is kind of familiar, but this next bit you have not seen. So very exciting. We're going to be talking about actually accessing peripherals. This is a relatively new capability. Accessing peripherals is really important for edge devices and edge computing, because often that's sort of the most interesting thing about the edge devices, what's attached to it, where it is, what sensors it has access to. So we've been building out a bit of a sort of starting to build out a library of peripherals, interesting ones, and sort of experimenting with this. And the main challenge and what we're interested in here is just, yeah, how do we enable accessing these peripherals from your containers? And so we have a system in place that allows this to happen. And this notebook, which is part of the user guide, goes over one example. We have a Raspberry Pi camera module connected to both Jets Nano and a Raspberry Pi. I'm going to be showing its usage on the Raspberry Pi, but going to be basically pulling in some pictures from a low camera that's stuck to a window in my apartment, actually, in Chicago. So I think for this one, I'm going to just reuse, at least I already had for this from my Raspberry Pi. You do kind of have to understand currently which devices have what peripherals attached, but this is something that we're going to make easier to do on like a reservation basis. So if you just care, like I just want a camera, we should be able to support that. But currently, if you go to our hardware page, it will tell you which peripherals are attached to which devices. So I prepared a little Docker container. And basically what it does is it uses the Pi camera library to interface with the camera. And notably, I'm just going to make this a bit more obvious here. We're going to be using this new argument called device profiles. And it just kind of says like, I want this container to have access to this device. In this case, I want to say like, plumb the Raspberry Pi camera into the container so that I could access it. If you've worked with containers and devices like this before, this is kind of like a little bit non-obvious and a little bit annoying to do. So we're trying to make it as easy as possible by just saying like, give me a camera, you get the camera. I'm going to expose my port 5000 because I'm going to use that I'm basically going to use that to serve a video feed of the data that the camera is pulling out. So that's going to be creating that one now, I hope. Okay, you can see that it is creating the container. And so if I go back here, yeah, waiting for a container to start. Just give it a second. I should also note that if you're playing with the Edge testbed and it seems like things are taking a while to load or to launch, we sort of lazy fetch the Docker images. So if you're using an Edge device and you launch the first time and it's a fresh image that the device doesn't have in its cache, it'll take a little bit because it has to download it and write it to it, and usually an SD card, which is kind of slow. But subsequent launches of the same image will be fast because it will be cached in there. Okay, similarly to the other one, I've got to access this thing over a public IP, so I'm going to attach one, and then I'm going to be accessing a stream of the video feed. And so I'm using this IPI widget, another built-in, just stupider thing that people use for all kinds of stuff. It's got a way to display an image from a URL, and we're going to try that. Cool. So this is showing, I don't know if you'd actually tell, but it is sort of moving a bit because it is pulling frames from like a live feed. So you can see the trees are moving slightly. The camera is a little bit cockamamie on my window. Sorry about that. But that is a feed of what's happening from that container with that video attached. So yeah, that's kind of the newest capability that we have in addition to the restricted devices that Kate mentioned before. But we're looking to sort of expand the catalog of types of peripherals that we support. And a lot of that is sort of also what Zool is working on investigating. She's, if you know her as a Chameleon appliance lead, she's kind of also taking a look at that for the Edge platform to make it easier to package and access these various interesting peripherals. We also have done some work with making GPIO interfaces on the Raspberry Pi accessible, as well as we've experimented with SDR, making those accessible from the container. The last thing I'll note, this isn't quite a peripheral, but if you're running on the Jetsons, which we have several Jetson Nanos as part of the Edge platform, you can also, you're able to basically make a request for a container that will have access to the GPU, which is probably what you want a container on a Jetson to be able to do anyway. But so that's also possible. It's not really a peripheral, but the general, I guess, idea is containers should have access to the widest range of capabilities that the Edge device can provide. And so while we want to keep the sort of isolation, both from for your own benefit, but also from a security benefit, we do want to be able to provide as much capabilities of the Edge device as possible. And yeah, I think that's the end of what I was going to show, and I can see Kate has joined us again. So I'm going to maybe step out for a second, and I'm assuming there's going to be some questions. Thanks.
Yeah, thanks, Jason, very much. Fabulous demo. If I may just share the screen for a little bit and wrap up with a few thoughts on the status. In the meantime, we've got a rousing discussion going on in the Q&A channel about various different capabilities. Okay, so I'm back here again with just a wrap up. Important thing to remember is CHIEdge is currently in preview, right? So we've got a reasonably featureful and reliable functionality core that is based on a mainstream open source project, but obviously we had to extend it and adapt it in many ways in order to satisfy our use case. So there are many things that we're still working on. More features, in particular, networking right now is handled in a very simplistic way, and there are many, many other features. We would like to understand what other features are that you and your project need specifically. We would like to make it with more hardware, with more peripherals, and we'll probably do for a significant implementation refactor and maybe even a bit of a pivot. So I would say, though, that the main thing, the main reason for why CHIEdge is in preview right now is not necessarily the lack of features or the quality of the implementation, but the inability to scale operationally right now, right? So the implementation needs to get a lot more robust and a lot more operable for us to take it out of preview. Like I mentioned earlier, the general availability of CHIEdge SDK is temporarily suspended. We're hoping to come back soon. We are working with some amazing partners right now and are fully occupied working with them. We'll need to focus on doing that for the next little bit. Also, we've had inquiries about CHIEdge in a box. So in other words, packaging of CHIEdge. So this is different than adding your own edge devices and having us manage sharing of those devices. This means that you're now operating your own sharing completely independent of Chameleon. This is suitable for projects that are providing a platform where different application of communities might leverage it, right? So similarly to Chameleon. And we, again, have something that is in restricted availability right now. We're working with specific partners on that and are evaluating it. For roadmap, we have some plans for the next few months, but essentially we organized this workshop in order to understand what features you want and to prioritize those features in our future development. And then, of course, we're looking for technical partnerships. So we're working already with OpenStack. We're meeting with various OpenStack projects next week. Very excited to do that, to understand how we can work on developing CHIEdge or an edge platform in general together. But those platforms are very expensive to develop and operate, and we essentially would be happy to partner with others who have an interest and expertise in building similar systems. So those are just a few words to wrap up. We've had a rousing discussion on chat and on the Q&A channel, and please continue posting those questions there. But I was wondering if there are maybe some live questions for either myself or Jason's excellent demo. So let's see, do we have, I'm going to stop sharing. So I see no new questions in.
There was a question that I just answered, but it might be worth elaborating live. The question was, does the live camera belong to me or the device? And I think what the question is maybe getting at is like where was that camera like plugged in, or where was it? So just to make clear, so one of the device I was running on is a device that I contributed to the Edge testbed. It's currently physically located in my apartment in Chicago. So it's hooked up to my like residential network there. And but one of the nice parts about the Edge platform is it does not require, I don't need to allow any inbound connections to that device. And it's, so I could, I can basically firewall off that device. As long as it has access to the internet, I can enroll it into the CHIEdge platform and use it for experimentation. The camera is physically connected to that Raspberry Pi. It's a Raspberry Pi camera module, which runs on, it just connects via a camera serial interface. So yes, it belongs to me technically, but it's physically connected to the device. And even if it, and importantly, that device currently is allowed, anybody can use it. It's not restricted actually. So somebody else could launch a container on the device that has access to that camera, which is why it's pointed outside.
Yeah. Okay, and I think that we are exactly 3 minutes late. So we will let everybody go off for a short break and hope that you will all come back at 1 p.m. Central Time, whatever p.m. or a.m. that may be your own time. We've got some very exciting presentations from CHIEdge users, and we're going to do that in the next session, and we're going to have a discussion to follow. So please continue asking questions on chat and on Q&A. We'll be happy to answer them. And we'll see you in 12 minutes.